Hi, my name's Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So, welcome to O-Day, HCNO, and that's me talking to myself. Welcome to O-Day, HCNO, this 24th of September 2023. Hi, Klingon Baroness Princess Carla Nipton Hutchison. Great to have you in the house. DIY projects with Chowxes. You got up this morning. That's very good. Hi, Creating Awareness, Corky Goss, Ken Pratt, Artifact, D2105K, Gordon Doherty, Tony Yaboni, Rhett Oracle, Space Case, Cosmic Dave. It's great to have you here. So, apologies for not being with you last weekend. I had a significant sequence of conversations with people involved with the thunderstorm generator, Malcolm Bendel and others. And so I have been doing what I can to help them understand from my perspective what I think may be going on. And of course I may be wrong, but from my perspective, one of the key things with a technology that uses this process is safety, and I will help them in any way possible to understand and maybe detect and mitigate for any potential things that are going on. If I can find the video that I want to show you, it's really what convinced me that probably I should be engaging with them. And so thank you to the Robert that sent that to me. And let me see if I can dig that out right now. I didn't want to do that right now, but I'm going to. So let's see if we can find that. So bear with me. Can you let me know if my audio is seeming to be okay? Hi, Harry. Hi, Creating Awareness. Tammy. Starfish Troopers Podcast. Simeon Hein. Thank you very much, Elias Landhart Graham. Thank you for letting me know it is okay. Hi, Stuart N. Right, give me just a second to see if I can find that, because actually I should have had it ready, but then I didn't because I forgot about it. These things happen. I hope everyone is very well this day. Okay, so la-di-da. Give me a few seconds here. See if I can find it. No. Let me go and see if I can find it in my emails. Sorry. Completely forgot about that. It's kind of like the introduction. Okay. Well, I can't seem to find that very quickly right now, but trust me, there was a lot of Evos flying around. Essentially, it was one of these thunderstorm generators, and it was a test that was done in Thailand, and you can see the lights coming around. Apparently, the video is made public, and I've been given permission to share it as well. So maybe we'll find that a little later on, but I can't find it right now. So let's get back to the main event. Hi, Tucker Tries. High geometrics 999. Okay. Let's forget that for a minute. Okay, so what are you looking at on the screen here? On the left, we've got this kind of yellowy, bubbly fluid down the bottom, blending into something that looks like some crystal blue water and then going into the sky, as if you're looking through some sort of oddly mixed thing. Oil normally floats on water, but not exactly what you expect, but I don't think this is going to be what you expect. On the right, you can see a petition. And this was very weird, because I wasn't going to talk about what I'm talking about tonight. But as I was walking up the street to our office, where I'm filming this right now, directly opposite where the office is, there was my friend and colleague, Emmanuel Ruggiero, who I share an office with, and he was actually pointing his camera to the other side of the street. I said, Emmanuel, what are you doing? He says, I'm taking a photo of this protest over there. It's a petition. I think it's quite funny. And essentially what is being said on there, I think someone worked this out there, is let's save petrol and diesel cars. That's the petition. And it's saying, let's say no to the banning of combustion engines. And it's for freedom. And I thought that was quite interesting. Why did I think that was interesting? Well, typically, students are the kind of people who go with the narrative, who are doing the latest thing that they should be following, because sometimes they can be impressionable. But here in the Czech Republic, and it may be somewhere else, I don't know, but typically the Czechs don't like being told what to do. They learned the hard way that just following along with what someone is telling you to do doesn't necessarily lead to good long-term outcomes. So hence we still have the Czech koruna here, and other things have been resisted in the past. They have their own very strong national identity. And so when I saw this, and in the context of what I said earlier in the year, in February, with regard to the Geet, which we'll just have a quick look at, and also with what I've been hearing from the testing and verification of the thunderstorm generator, which in a number of respects is producing the same toroidal geometry, fractal toroidal, exotic vacuum object type structures, as was seen to a degree in some Geet videos. But this video that I haven't shown you, that is apparently publicly available, and I will make available on the blog for this, was showing it in the extreme, was enough for me to say, yes, okay, this definitely is using this technology. And the things that they were saying, having tested it at an independent lab, I think this is a very interesting development. And so I will refer you back to one of the early Geet videos, which was, can we run the world on cow farts? Here we are. And I will give you a review of just one of the comments that I made during that video. I won't obviously tell you through the whole thing. I said, you know, they are going to ban diesel generators and petrol generators if they can get away with it. This could be the world we are moving towards. We're not allowed to a gas stove in our kitchen. We're not allowed a hydrocarbon-driven car. We're not allowed animals that provide us healthy, nutritious food. No, we've got to turn this on its head. We've got to use their arguments against them. That's what I said way back on the 5th of February 2023. And you can go and see for yourself on that link. Since then, the UK government have rolled out this plan where you're not allowed to have, in the near future, natural gas-powered heating in your home. You have to replace it with a heat pump. And so there definitely is an intense desire to remove the freedom that for instance, having a diesel car, you could make your own biodiesel. And we discussed the fact that using the Geet device, potentially you could use any form of carbohydrate or hydrocarbon in the device. And I looked at the methane molecule here as being possibly the most beautiful molecule that might explain an observation that was claimed by Paul Pantone. And that was that they would get sometimes helium out of the device, and sometimes they would get excess oxygen. Okay? And I went on to explain, given the Parkhomov-inspired reaction tables that I programmed, or rather, I helped develop with Philip Power. He did the actual programming. I did the design at nanosoft.co.nz. And the idea was that you had two hydrogens coming in with an electron, coming in with a cold antineutrino, and we can debate whether that's synthesized in the process or whether it's captured from the toroidal moment from the environment, or whether it's an impact-related one over 5 electron volts as per Shishkin and Carol's, but it doesn't matter. A cold antineutrino, and that combines this proton, the electron, and the antineutrino in a sort of reverse neutron decay to synthesize with the other hydrogen, proton rather, the deuteron. Okay? And then if you get two deuterons coming together, you get the 4 helium. That explains the helium they observed. And then once you've got the helium, that combines with carbon in there, and you get 16 oxygen. And so for this process, you end up, if you were producing 1 oxygen from 4 protons, 2 electrons, 2 cold antineutrinos, etc., and 1 12 carbon, you would get a total of 32.45045 MeV, or about 6.5 million times more yield than C plus 2O2 CO2. So I thought that was rather groovy. And I said, what was the best thing for this? And I said, methane is the best, because it has this 1:4 ratio, and it provides you everything you need to get to here, other than the cold antineutrinos that would be supplied by the overall fractal toroidal process. And so the thing that would do this is our friend, which doesn't necessarily need to have this level of fractality, but here is an example. And if you can imagine, the material in our soliton vortex here is going around here, round, and some of it gets pulled back through the middle, and gets pulled back through the middle, and gets pulled back through the middle. Now, if you go and look at the remediation work that I discussed many moons ago, they show a diagram where there is a toroid. They don't give any sort of substructure to it, but they show that this is negative, and around the outside you get these positive ions, okay, floating around. I guess they're attracted, okay, to the structure itself, okay. And this is something that we talked about in the last presentation, HHO, and I referred you to this 1994 Sundaresan and Bokras work, where they saw the production of iron, and they claimed it would need to have helium if this was the reaction pathway, but as far as I know, they didn't look for helium, and I made another proposal for that. But in this slide, you'll see you have the CNO, and we're going to talk about that. So the HCNO is not some nasty chemical that some people guessed it might be. I'm talking about the interaction between hydrogen, carbon, nitrogen, and oxygen. And one of those reactions we looked at, I proposed as a method for synthesizing 17 oxygen And this was confirmed, it would appear, across multiple and only heat-generating cavitation reactors by Binzhi and Huang at Taipei University Department of Energy, and using gas analysis done by people who do the gas analysis for the Taiwan semiconductor industry. And this is this key reaction here, which is key to making the deuteron that I was referring to in February, and that is the 1H1. This is proton plus an electron plus an antineutrino. Add those all together at the same time as combining it with the 16 oxygen, and you get 17 oxygen. And the follow-on reaction is, in fact, you have two of these occurring at the same time, because you would have 16O2, and you end up with two 17Os, 17O2, and this leads to the production of carbon and neon. And relating that to the Sundaresan and Bockris, I suggested that their iron actually is something very similar, but instead of one 16O2 becoming one 17O2 and producing 12 carbon and 22 neon, you actually get two 16O2 becoming two 17O2, effectively 4 17 oxygens synthesized, and they fused and fissioned to 12 carbon and 56 iron. And the energy is almost exactly the same as was claimed by the reaction by Sundaresan and Bockris. Sundaresan of the Monatomic Research Center, Nuclear Research Center, that did the initial Pons and Fleischmann replications in Delhi with Mahadev and Srinivasan, and John Bockris, one of the world's greatest ever electrochemists, and he was at Texas A&M. And so I've argued that this might be the process that would account for ball lightning, crenellated iron-rich, and iron or oxygen, actually, rich spheres. For the ball lightning-based or coherent matter, I believe, structure that produced the same kind of structure in Alan Goldwater's ultra replication. And note, on the outside, it has this kind of film, and the film is silicon dioxide. Okay, so you have iron oxide and then silicon dioxide. Silicon and oxygen are the most abundant elements by far in the Earth's crust. Okay, iron is one of the most abundant elements. And again, this is in Henk Uren's Vega experiment, this iron and oxygen crenellated sphere. Now, this is where it got interesting, because and I will publicly share the first discussion I had with them, my bits, and and so forth. But they said that, like the Geet, they were not seeing, or they were seeing extremely depleted, and I need to verify this. I need to see it up personal, and I hope to be able to do that in the next couple of weeks. No or very little CO and also CO2. And I said, well, probably you're getting something similar to what was observed in some other experiments, where the carbon forms a glassy form of carbon, or this diamond material, which was observed on the Constantan wire of Francesco Celani, and inspired me to suggest using nickel diamond reaction matrix, and that led to Neil Creighton Gold's Lion reactors, and the Lion reactors led to a lot of the understanding. And so it was a one virtuous open research cycle. And so the other thing about the Lion reactor, as you recall in Mining Diamonds with Lion and other work that was shared around that time, is the diamond gets consumed, and it has these little miners that are going in the diamond and consuming it. And in fact, in one case, it was a whole sphere, and the sphere and the ejector from the sphere matched the 3D geometry of the fractal toroidal structure. So we've shared all that before. And so the diamond seems to be able to go into the process. And we're going to talk about that because, you know, I've said to one degree it doesn't go in because it's diamagnetic, but I'm going to show you how it can go in. And this is going to connect back to the previous presentation. So that is a couple of cases. There's also the diamond film that was observed by Leclerc in his cavitator on aluminium with water. And so carbon seems to appear, but what also appears, as I've just shown you here, and I'm going to give you other examples and the raw analysis data, is this silicon dioxide, okay? And then you also have calcium oxide, okay? Now, if you can imagine what powdered silicon dioxide looks like not sand, I mean really, really fine powder, well, it would look white, wouldn't it? And also, obviously, calcium oxide would look white as well. And if you did have extremely fine calcium oxide, we all know what that does. It absorbs carbon dioxide to make calcium carbonate. So with the carbon potentially playing a role in forming silicon, I'm going to show you this. Carbon and oxygen can form silicon. That's carbon-12 and oxygen-16, for instance, confused to form silicon. Yeah? You can have that go on with, for instance, carbon-12 and silicon-28 to form calcium-40. So I'm going to show you these. It follows logically that this process potentially goes through some sort of proton chain, but not necessarily, only needs to necessarily make deuterons. Or it all happens simultaneously, which I believe is actually quite likely. But I will show you the logical steps. So you get carbon synthesized, maybe. Then you get oxygen synthesized. The oxygen plays a bigger and bigger role because it's this paramagnetic material in any state. It doesn't matter whether it's atomic, a molecule, or ozone. It doesn't matter what it is. It's always paramagnetic. So it's a really good anchor for the process to occur. And then you've got electron itself, a free electron being paramagnetic. We discussed this. A proton or a proton with one electron, atomic hydrogen, being having a magnetic moment, and these all align with the magnetic field of the fractal toroidal structure, whichever way it is, whether it's a yin or a yang. And so it's a reinforcing process, and it's punching that stuff through that central zone here. It's all of this material is flying around here, and I will do a lovely animation of this. Maybe someone will get there before me. It's flying around, and it comes through, and it has this phase singularity where maybe the fractal toroidal moments arrange it in a sphere or a torus or whatever, depending on the intensity of the moments and so forth. Whether you get the vacuum structure, the vacuum currents producing a torus or a sphere. And so it gets arrangement of the material, and you can imagine that some are more paramagnetic, some are more diamagnetic, depending on their state. And so you will get an arrangement of the material around that. Okay, so what I suggested was, you should see these things made. And I said, like, possibly what's happening is you're not seeing carbon dioxide and carbon monoxide because it's actually producing solid carbon, this kind of glassy carbon that gets produced in films, or it's producing diamonds, or which we see on the little tips of the carbon in the Vega Valley, and on the experiment by Leclerc, and on the experiment by Francesco Celani, or it's producing silicon dioxide, or it's producing calcium dioxide, or even it's playing a role in even getting up to iron, perhaps. And so the material is becoming solids. So you're not observing the gases. So it's effectively sequestering the material. Now, I'm going to give you a whole bunch of data here to support this argument. And by the way, they have said to me that they will give me... Well, actually, so, okay, I'm missing one bit here. They said they're observing a white powder. And I said, well, you know, this could be what it is, this white powder. And that is where the carbon is going. It's either being converted into other elements, or it's being forming a solid, or it's, you know, essentially being captured as carbon dioxide into calcium oxide that is formed as well. And you're ending up with this byproduct, which is effectively powdered rock. To all intents and purposes, you know, silicates is most of what the crust is, and if you add calcium and the other elements that you'll see are likely to be synthesized and actually are synthesized in ball lightning, and since what I've seen in this particular video absolutely looks like ball lightning, it's almost certainly what's going on. And so let's have a look. So I'm going to share now the image that I gave as part of a poster here. This is a copy of it to one Takaaki Matsumoto earlier in the year. Thank you for those people that made that possible. And this is the image, and as you can see up on the top left here, these are all at the same scale. So everything you're seeing here is at the same scale. Okay. Actually, that's not true. At the top here, this is a 1 millimeter scale. I think the bottom here is the same scale as this. This is 100 microns. This is 200 microns. So this is the same scale as this, but this is a lot bigger. Okay. In this one, Matsumoto observed the generation of carbonized film. Carbonized film. Down here, he's got carbonized film containing iron. And actually, there seems to be a sphere down the bottom here. Maybe that's iron in a crenellated sphere, but it's not clear enough. But anyway, he's saying carbonized film containing iron. Over on the right here, you see this film, okay? And in the film, we've discussed it in the past. There are crenellated spheres here, 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 and they're always on the, or very typically on the perimeter of the carbon film. So it's like they have come out and they've left it behind it. There are also tores. There's one here, and there's one over here, and there's one over here, and we're just going to have a look at a couple of those. Here is one tore, and as you can imagine, there is a carbon at a diameter from distance from this tore. There's carbon in the center. But when you actually analyze these in these kind of scenarios, they tend to be very pure calcium oxide or very high calcium oxide. So the actual tore of tores is made of calcium oxide, and this boundary zone is this carbon predominantly that gets transported around with it. Again here, one of these calcium oxide tores of tor. And this is actually right in the middle of that structure, so it has some fragments, possibly of even part of itself here as it broke up. And then it's just in this sea of carbon, okay? Again, the one on the right here, and it's not just carbon in here. You will see these are all of the elements you would expect to be synthesized. Here is one that broke out and it flew off, and as it was finally dying and the wave function was collapsing, you are seeing this trail of carbon. And this implies to me that it was pushing into the surface as it crash landed. And the remaining flux of carbon that was orbiting around this structure was forced into the center, and it left this trail. That is how I see this occurring. As originally it crash landed here, and it came to a stop over here, and the remaining stuff that was spinning around here got deposited as it lay down on the zinc oxide here. And you're going to see that that's zinc oxide. Now, here is a whole ball lightning structure that blew up in isolation. So this may be a tor. Like I say, the phantom may create tors or spheres, or they may actually have a sphere in the center at the magnetic core. You know, these things need to be resolved by more observation. But both Ken Shoulders said that they could take the form of tores or spheres, and this is also what Matsumoto observed, tores or spheres. In this case, this one blew up, and the very main elements, iron with oxygen, silicon with oxygen, and calcium with oxygen in this structure is what was observed in the only spectrum of ball lightning. Now, this isn't all that's there, and we're going to have a look at the data from this, which I haven't gone into as much detail as I'd like to have done in the past. But I have done a little bit, but we're going to go into full detail here because you're going to see all these particular elements in this overall structure here. You can also see some more clarity. This is looking at this same structure with a different detector or a mix of detectors. Actually, this is the BSD full. So on this one, I can't remember what it was, but this is the BSD full. So this is actually showing the different elements here, and you can see that it has something that's almost orbiting around the central point here. Now, if we go back to this one produced in an ultra experiment, this material here does appear to be at least all the way round, but not at all here. So maybe it was orbiting around this central plane, and so maybe that explains why we have a lot of this silicon dioxide here, but there's none of it up here. Is that maybe it has this kind of like almost like Saturn rings. You can imagine things orbiting around, or even like the planets around the sun. It's kind of got this central plane, and it might be to do with this might be the magnetic north or south, and this is just where the material accretes. It's like the accretion disk on a black hole. Oh, maybe it is a black hole. Okay, so this is the same thing but up close. So I'm looking at this bit here, and you can see if I go to the next slide, this is the bit that I'm talking about, this accretion area on the central band here. Okay, very, very clean up here, not so clean down here. Now, the second thing that I'm going to... Actually, let's look at this data in its entirety. I'm going to pull up the document for this particular thing here. Let's see if I can find that file. This one, I think. It's going to give it to me. Yeah. Okay. Okay, we got lots of lovely data here. Lots of yummy, yummy, yummy data. Okay. Vega Eastern Plateau. And this was done on a Phenom workstation in Prague. And here we go. This is what you've just seen there, the ball lightning. And at this level of observation, using a map, it's picking up carbon, oxygen, silicon, calcium, iron, and then, of course, we've got copper and zinc. We should expect copper and zinc because it's on brass. And so, obviously, the zinc is all over this area here. So, it's going to represent as a lot of the weight. So if you could ignore that, you'll see that essentially it is mostly, other than the copper and zinc that was in the original material, you are mostly looking at carbon, oxygen, silicon, calcium, and iron. Exactly what we see in the ultra experiment of Alan Goldwater. Okay? Looking at a map here, you can see the carbon is spread out in this. You can imagine the sort of birdie, but it's kind of blown up, and there's a bit of a kickback as it collided into the surface. Okay, you can see the arrangement of the silicon fragments here. You can see the arrangement of the calcium. Quite a lot of calcium here. Okay, in fragments. Note they are in fragments, and look at the size of these fragments. Okay. This fragment, this is 30 microns. So the biggest of these fragments is like 5 microns. Smaller parts of these fragments are 1 micron, maybe even nanoparticles. So if it would seem, and I'm almost certain, that the thunderstorm generator is producing ball lightning, fractal toroidal clusters, those type of things, when they are blowing up they are spilling their guts of material that's been grabbed together and also potentially transmuted. It's going to produce these fragments of particles that would, in calcium oxide, definitely appear as a white powder. As silicon dioxide, definitely at this sort of scale. Again, this is 5 micron. This has got a width of about 1 or 2 micron. This is dust. This is dust. Okay. Iron. The iron is extremely and precisely the sphere in the center. There seems to be a little bit down here and one bit there, so semi-equidistant. What do they look like on the map? On the actual image, it might be this little blob here, maybe something up here at the tail end of this, and then there's some structure down here. This has some iron in it. Okay, so maybe we can learn something from that. There's also this wonderful triangular thing down here, which has got truncated corners. I don't know if you can see that. We should probably have a look at that at some point. Okay. Calcium, we looked at. Iron, we looked at. And copper. Copper is obviously some of the starting material. And you can see there are small fragments of copper everywhere. Okay. Is it coming in sort of spiral here? Maybe. It looks like we got a spiral coming around here. Spiral comes around there, comes around there. Maybe. And there's some sort of semi-equidistant spacing between these bits. Is that relevant? I don't know. More study needs to be done. Okay. Zinc everywhere, as one would expect. Right, now, we're looking at something else here. Again, we're going to look some spots. So the center spot here, this sphere, and we're looking towards either the north or the south pole of the structure here. What do we see? We see atomic concentration almost 50-50, 42 to 58. One might imagine some extra oxygen on the surface. Is this FeO? Possibly. I don't know. Spectacular if it is. Okay. Is the water in there? I.e., is it FeOH? Maybe. I don't know, because we can't detect hydrogen with this. I don't suspect there is. But anyway, this is what we're seeing. We're seeing this 42 to 58. Basically, pure iron oxide in that center. Nothing at all on that part of that surface. If we go and look at this blob over here, we have oxygen, a lot. Silicon, sulfur, a lot. Now, we all know that sulfur is 2 oxygens fused together. We demonstrated that in an HCNO experiment on one side of a monopole sacred geometry structure. The snowballs on cobblestones video, where the oxygen was eaten off the copper oxide and formed sulfur. So that is not surprising to find that in here. Also, you get a sulfurous smell when a ball lightning blows up. Calcium, 30% nearly. 30% calcium over here. And then we've got the copper and zinc, which was in the starting brass. Okay. Here, the spot over here, we have some sodium creeping in, some aluminium creeping in, not unreasonable amounts of atoms there. We have some potassium creeping in, okay? Very, very interesting when this is otherwise just almost entirely zinc oxide and it was brass. So we have, see, there's basically no copper. The zinc is almost below detection threshold, but we have potassium, aluminium, sodium, and then the silicon, oxygen, carbon in this part here. This little sample here looks like it's a piece of zinc here carried, but again, a lot of carbon and oxygen. Here, again, a sample from the other side, a lot of, some calcium and mostly carbon and oxygen. Look at that, 74%, 73%. Another sample here, calcium, 11.5% there. 25.5 by mass, a lot of oxygen there, and carbon. Now, is that CaCO3? I don't know. It might be CaO. It looks like it might be becoming calcium carbonate. I don't know. Getting close. Here again, I'm doing a line scan across this zone here to see the change on the overall line scan there. A lot of iron, obviously, we've got that in the center. Good chunk of silicon. Detectable calcium. We know the calcium is in one particular area. If it missed it, it missed it, and so forth. Aluminium, potassium, and so forth. And if we look at the line here, it's very, very distinct. The oxygen and the iron is where the ball is. There's this little kick up over here. What is that red line there? I suspect that's probably silicon. No, it's not silicon. What is it? What is it? What is it? It is... Oh, that's zinc on that edge. Okay, interesting. No, carbon. Oh, that's carbon. Oh, right. So, okay, that kick up there is carbon that's orbiting around this accretion area here. We got another... The carbon is kicking up there, and then right over here, lots of carbon over there. So you can see... Oh, sorry, that isn't carbon. What is that one? Keep saying it's carbon. No, that'll be the zinc. The red one is the zinc. Sorry, excuse me. This is the zinc. So it's seeing the zinc on this edge through the gap there, and it's seeing this. This is the substrate. This is the background that the ball lightning crashed onto. So what do we see the arrangement here as? Carbon comes up, peaks. Okay, so that is carbon. That is carbon on that edge. That orbiting bit around that accretion disk area is carbon. This is all carbon through here. You can see here the carbon comes up there. So this is all carbon here. This is all carbon here, or rather high concentration of carbon. Oxygen. Okay. Aluminium. Look at the aluminium. It's it's located very specifically. It's kind of like in this area here. In this area here, you've got the aluminium. Obviously, aluminium is the third most abundant element in the Earth's crust. Silicon, there we go. The second most abundant element in the Earth's crust is co-located with the aluminium, pretty much. It kind of rises a little bit sooner and almost falls off at the same point, but it's got a higher intensity. Of course, silicon is the second most abundant element. Aluminium is the third most abundant element. You're literally seeing here ball lightning creating the proportions of elements in the Earth's crust. Obviously, oxygen is compared with both of those things. And here we got potassium. Potassium here. 0 potassium where the iron is, and 0 potassium where the zinc is. But the potassium starts before the silicon and the aluminium and spreads all the way across both structures. Calcium is like in waves. We've got a chunk here, a chunk here, a chunk here, and then the iron is arranged like that. The copper is just coming into the gap where it gets seen, and the zinc is just looking through to the original substrate here. Okay, so that is this ball lightning breakup in detail. I will share the PDF of that analysis. I think it's extremely valuable to know that. Hold on, did I miss anything? Was there anything? There's more. There's more. I've got more beautiful data to share with you. Okay, all right, look at this. We've done a closer section here. Again, we're seeing carbon, oxygen, aluminium, silicon, sulfur, potassium, calcium, iron, and then the original starting materials, copper and zinc. You can see where you don't see anything here, this is where the beam can't reach it. So maybe the beam, yeah, anyway, it can't reach it. So those are the proportions, okay, in that particular sample area. And so here's a close-up in the area on one side of the breakup, and you can see how the carbon, this is where it's able to detect it. So the carbon is kind of these areas. Oxygen's kind of everywhere. Aluminium, again, that's that blob of something with high aluminium. It's somewhere in here, somewhere in this part. Of course, aluminium and silicon are very close. One's 27, one's 28, isn't it? So silicon and aluminium are very, very co-located. Look at that. So the synthesis is very close to each other. And when you think about it, it's just adding one proton in there to go between those two elements. sulfur out at a distance. The potassium, that's interesting. The potassium seems to be around that central silicon and aluminium block. There. And then the calcium is not at all in that bit, and it's on the outside of that. And then our iron sphere is just an iron sphere. Look at that. It's all on its own. Really distinct. Interestingly, look, there seems to be a periodic copper deposit around. Is that around the iron sphere? Yep, it's around the iron sphere. So in that carbon that's orbiting around there, periodically you've got spots of copper. That kind of lines up with the spots of copper that are coming in on in the vortex, maybe. Okay, and the zinc is wherever it is because it's the substrate. I've got, what else have we got here? Did I really go to town on this? Is there more? I think there's more. Yes, there we go. Oh no, this is a different sample. Okay, so we'll share all that analysis and you can look it over. But that is that. So I'll go back to here. So the next one is flux loops. We found on the top of the Lion large, the original, if you can remember, the white vortex structure, there was a flux loop coming round and it hit the top of the Cantal wire, and in the center there was calcium. Where had the calcium come from? Let me see if I can find that image for you of that analysis. I think I've got it here somewhere. Let me see. Let me see. I've got it somewhere, I think. Okay. Yes. So thank you to Alan Goldwater and his Magic Sound Lab. This is the storm, as I call it. I've shown lovely microscopy images of this. And this is on the top of the Cantal wire, but not on the bottom. So we saw the fact that the flux loop was literally going round in a loop and hitting the center of the top of this. And we have this overall kind of deposit on here, and it's very ordered. You've got this, whatever this black stuff is here, and then further out you've got this whitish deposit, and then you've got this kind of deposit, and then outside you've basically, on the outside, you actually have like mini Evo strikes here. This is what I'm saying. You always get the really interesting stuff on the periphery. Okay, so these are just like almost like Evos that are being captured by the Evo, the macro vortex structure. They're traveling along with it. Okay, here it is using a different detector setup, and another one. Okay, I need to see if I can look at that. I think those are the actual data. These are the crystals, and from recollection, because I can't find the actual data right now, these are calcium rich. There is nothing else anywhere else, but they're like crystals that formed. And if you look where they are, they're actually in this central area here. These crystals here. Okay. And there's some diameters. You can see this is across here is the 593 micrometers. So it's actually fairly physically large. And I've got some other measurements there of these various subsections of it. Okay. So I think the key takeaway is here. Now I'm going to show you another piece of data which came much more recently, and that is the Vega cardioid infarction. Point to note here is if you go back to my ICCF 22 presentation, there I talked about the fact that in Parkhomov's 225-day reactor, the inner core went from 1 to 20% carbon. Sorry, that should actually be calcium. Sorry, I'm being an idiot. Let me just correct that. Yeah, I'm glad I caught that. High quality presentation tonight. Okay. So, what was I saying? Yeah, the inner core went from 1 to 20% calcium. Now, one potential way is the active agent causing a fractioning of the tungsten heater coil. The other one is the fusion of the silicon carbide core, fusing silicon and carbon together to make calcium. So 28 plus 12 is 40. That gives you your calcium, and we'll show that. Okay, and now I'm going to show you the Vega cardioid infarction. This is new data. And this is got what we call the Dimple. I shared videos of this during the last week. And this is the center of the dimple on what I call the cardioid infarction. And for those that don't know what I'm talking about, it is the brass sample that was part of the arrangement where we had Henk Uren arrange this soft iron block with this piece of brass here, okay, and it is the dimple. Well, what we're looking is at, we're looking at the center of the dimple, which is under my finger there, right there. Can you see it? That dimple, not the hole, the dimple, okay? Because I wanted to see if there was actually a hole there. And there kind of isn't, and there is. There isn't, and there is. There's a feature there in that center, okay? And that is what we are going to look at now. Okay. So, this is the center of the dimple. Now, when you look at it under some of the SEM images, it almost looks like there's an outie and there's an innie. And this would be similar to, if you remember, the first double helix vortical structure I saw coming out of the cavitation spot on the Amasa vibrator plate with a polarizing filter on the dynamite. That had these two vortices coming out. We've seen this coming out of Henk Uren and David Bitlier experiments, and it might be that there is a double vortex coming out. It might be that there's one vortex coming out and another one coming in, okay, within the center of this. So, you know, with that in mind, I think maybe something is coming out of here and something is going into here. And this is the center of this flux loop that connects one side of the charge structure to the other side of the charge structure, the yin to the yang. Okay. And I think it kind of logically makes sense that this might be the case, that you have two features here. Anyway, let's look at what we are seeing in this structure here. Well, looky here. We have carbon, of course. Atomic concentration 35.448. Nitrogen, interestingly. Of course, this is in residual air, so there's no reason why we shouldn't have nitrogen. And then we have oxygen. Well, okay, what have we got here? We've got CNO. We've got the CNO cycle, the carbon, nitrogen, oxygen cycle. Maybe that's what's going on. Hold your thinking there. We have some sodium, we have aluminium, we have silicon, we have sulfur, we have chlorine, we have potassium, and here, calcium. Of course, we have calcium. Oh, and we've got iron as well. Well, now, we do have iron on the base plate, so we can't call this synthesized iron here, okay? But this is what I'm interested in, the calcium here. We've got the silicon and so forth. And it's in this central structure here. Okay, so I did a map of it, and you can see the elements. Now, this piece here looks like a piece of detritus. This looks like a piece of zinc oxide fleck that's landed down on here. And if we look at the elements, these are the same elements observed. We've got sulfur there. They're very, very clear peaks, by the way. There's no ambiguity here. Plenty of samples as well. And so if you look at where the carbon is, it's kind of basically all over a little bit. Oxygen is obviously everywhere. The aluminium is in this main band here. Okay, so it's kind of like this here is the aluminium, not really outside of that. Again, the silicon here, again, is co-located. Aluminium and silicon co-located. Aluminium. And for me, the aluminium and silicon co-located is one of the signatures possibly of it being synthesized, because they are so close as in terms of their nuclei. The sulfur kind of like is trailing off and going into this central point. Is this just an injection? Maybe. Don't know. Chlorine is not very much. Calcium, again, the calcium looks like it's co-located with the silicon and the aluminium now, and also with this trail off here of sulfur. Okay. The iron in this case, again, seems to be co-located with the trail off of the calcium and of the sulfur. What else do we have? Copper is everywhere that this central blob isn't. And zinc is everywhere where this central blob isn't, except for this fleck of detritus that is on the top. So it is, in my view, that this object that is at the center of the point where you would expect the flux loop to be occurring is comprised of elements that are either captured and concentrated at this point or synthesized. My feeling is potentially they are synthesized, because we've seen this in ultrasonic experiments. We've seen in other Vega experiments in exactly the locations of a ball lightning structure blowing up. So what you are kind of seeing here is one central flux loop, albeit be a very big one. And you can imagine that this might occur in all sub-Tor levels. Okay. And so that's just another example for you to ponder. On the other side, we have these flecks, which are again, this is around the hole. These kind of like at this particular point, we've got these flecks, and they have these elements as well. Okay, whereas the area in between is, other than the carbon, which seems to be deposited everywhere here, it's mostly copper. Okay. Because the zinc gets removed, kind of ends up on one side. Actually, we found the same thing with the 10 yen coin. Okay, so that is that. Okay, so just to go over a couple of things, you can go and look at the old work on this, the early work. This was the diamond in the Lion reactor. This is Neil Crichton Gold's Lion 2, because Lion 1 is still intact. So these are a used diamond. You can see these things consuming the diamond as they moved around. And here we go. These are the trails of diamond that are being consumed by this material. Okay. And someone proposed that they might be in pairs. There was also this discussion that carbon might produce carbon monoxide, and through the Mond process it produces nickel, and nickel then deposits on the diamond, and then there's this nickel, but there's no nickel crystal. So this could be a heavier element, and potentially it could be calcium and so forth. Unfortunately, with this particular SEM, when you're looking at this close, where you can see this entire full scale here is 2 microns. So like that is 1 micron. So this is 200 nanometers. These structures are like 200 nanometers on the long side. Okay, they are not big, not big at all. But they are consuming the diamond. Now, if they are consuming the diamond, as we'll find out, and producing gases like oxygen and nitrogen through the HCNO cycle, then maybe we are off-gassing and converting the carbon to nitrogen and oxygen. Now, to build on what I was talking about last week, the week before last, about when something is monoatomic, it becomes paramagnetic. I want to refer to carbon when it's in the monoatomic state. Carbon consisting of single atoms not bonded to each other, that is, monoatomic carbon, is very rare and unstable, and it can only exist in extreme conditions, such as in the interstellar medium or in the plasma of a carbon arc. Oh, what you mean, like the plasma of a carbon arc of Centilla's thunderstorm generator, or thunder generator, or in the carbon arc of George Ossawa, replicated by Sundaresan and Bockris. Okay, so we can get monoatomic carbon. Monoatomic carbon is paramagnetic, and it has a magnetic dipole moment that aligns with the applied magnetic field. So, if you have something, a process that is able to strip an electron off and break up carbon into monatomic state, then it will be paramagnetic, and it will add its magnetic moment to that of the fractal toroidal cluster. Therefore, monoatomic carbon is a paramagnetic species that has 2 unpaired electrons in its valence shell. Does the explosion in an internal combustion engine, is that sufficient to produce some monoatomic carbon that will then become part of a preconditioned or pre-synthesized exotic vacuum object, fractal toroidal cluster, a cluster that goes in there, and then add to its moment and then transmute? Maybe this is what's going on. Don't know. Maybe. Now, what about monoatomic nitrogen? Monoatomic nitrogen can only exist in extreme conditions, such as in the plasma of a nitrogen arc. Okay, well, you're pulling air into your Geet, you're pulling air into your thunderstorm generator. When you have an explosion, I would imagine that there is some synthesis of monoatomic nitrogen. That will be paramagnetic. Monoatomic nitrogen is paramagnetic, as the 2s and 2p orbitals are partially filled and have 3 unpaired electrons with parallel spins. These unpaired electrons create a magnetic dipole moment that aligns with the applied magnetic field. Okay? So again, you'll have something that in the actual cylinder, if you're putting a charge cluster in there, if you're putting a fractal toroidal cluster in there, if you're putting a vacuum current object in there, if you're putting one of these kind of manifestations in there, then it's going to potentially add to the magnetic moment that's going on. At this point, I want to talk about the solar burning process. Many moons ago, 6 years ago, I talked about the HCNO cycle, the carbon, nitrogen, oxygen cycle. That is what our sun is kind of currently doing. It's starting on it. And this is log T, so, that's all the scale that's on the source on Wikipedia. And then you have the triple alpha process up here. So we're going to look at these different process here, the official idea of what they are now. Okay, so first up, we have the proton chain. Now, I remember Piantelli saying, you can't fuse 2 pure protons, it's impossible. Okay, right? Well, it's the thing that starts the nuclear process according to mainstream physics in the sun. Now, I have to be honest here. I don't know any scientist that has ever lived that has been inside a sun. Don't know anyone. I don't think there is any scientist out there that knows of any scientist that's been inside a sun. This is a theory. It's a theory. But the fuel is protons, and out of it you get helium. Something happens in between, right? So if you're getting a 20 micron structure, according to the recent research that replicated the Japanese research from 1976, where you got over 1,000 Tesla in a soliton, where a laser was passed into a nonlinear plasma. If in that pulse situation you get 1,000 Tesla, why would you not in a resonance system get far, far higher? And they also identified in the 2021 work that the smaller the diameter, the intensity of the magnetic field goes up and up and up, like an exponent. Okay? So if you've got a fractal toroidal cluster where some of the current structures are in there are incredibly small, then the local magnetic field in them will be unimaginably intense. There's a mosquito. It's trying to bite me. I'm going to get it. If it's really, really, really intense, then and Lutz Yeatner has calculated using standard quantum mechanics calculations that it can go up to 50 million Teslas. Now, even at 1,000 Teslas, that's 20 times bigger than the strongest magnet ever produced for a fusion reactor by MIT. Superconducting fusion reactor, we're talking 20 times bigger than that. If it's 50 million Teslas, it's off the charts. So they are saying that in the center of the sun, our sun, which is not a big sun, our sun, you can get the conditions required for the PP chain reaction. The PP chain. So if you have something that is 5 orders of magnitude more magnetically intense than is in the center of the sun, it stands to reason that you could get the PP chain going on inside an exotic vacuum object, and probably more besides. So here we go. This is the PP chain. Now, in the PP chain, you have protons coming together, and they annihilate because it's all billiard balls to them, and off comes a positron and a neutrino. I argue that a antineutrino comes in with an electron, makes one of these into a neutron, and they become your deuteron. And you don't get wonky stuff going on. Like down here, you get gamma rays. You don't get the gamma rays like this, okay? But anyway, we're looking at making the deuterons, okay? History of the theory. It's a theory. A theory where no one has ever been inside the sun. No one. None that I know. Anyway, but he did consider the two, blah, 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 and this is part of body of work by Methane, I don't know whether I'm saying that right, that won the Nobel Prize in Physics in 1967. Well done, him. Okay, so history of the theory. So that's the proton-proton chain, blah-de-blah-de-blah, and that's how they think it works, and so forth. Okay? Now, if we go to the HCNO cycle here, the HCNO cycle is here, and you start with 12 carbon as your catalyst. And it goes by adding a proton and a collision. You have a gamma ray coming out, goes to 13 nitrogen. Let's look at it up close and personal. Then this decays to 13 carbon with a positron and a neutrino. Then a proton comes in, collides with it, produces a gamma ray, goes to 14 nitrogen, and then that decays. Sorry, that gets hit by another proton, and a gamma ray gets released, and you get 15 oxygen, which decays with a neutrino and a positron, and you get the 15 nitrogen, and then another proton comes in, and you get helium synthesized, and it goes all the way back to carbon. So we go round this loop. Now, the interesting thing is we are seeing oxygen. And for oxygen to be synthesized, you can't be going round this particular loop, because the only oxygen that's synthesized in this HCNO cycle here is this one that doesn't exist in nature, right? We've got 16 oxygen. We have 17 oxygen and 18 oxygen. They are the stable oxygens. So we don't produce an unstable oxygen. We produce a stable oxygen. And this is why I suggested that actually the process was, as I said, suggested back in February, it was this kind of process where you have deuterons being formed. And unlike their formation of deuterons, here we don't need positron emission, we don't need a neutrino coming out. We have the cold antineutrino coming in, either captured with the toroidal moment from the neutrino condensate in the universe, or gathered from proper charge separation of hydrogen, or synthesized in the Parkhomov method by over certain number of electron volts of collision over 1,000 degrees centigrade, which you could probably imagine in any of these scenarios would be occurring. Okay, so that produces your deuteron. 2 deuterons go to 4 helium, and the 4 helium goes to 12 with the 12 carbon to produce the 16 oxygen. Therefore, we get the 4 helium they observed and the 16 oxygen that was observed. Okay. But we also see nitrogen synthesized in some of these things. So is it doing this HCNO, and we're actually getting 12 carbon with a deuteron, making 14 nitrogen with a deuteron, making oxygen 16? I think we might be. Okay. Now, the last part of the... So this is the CNO cycle, and it goes down here. This is the predicted chain and so forth. And then when you get like super high temperature, okay, you go to the triple alpha process. So what is the triple alpha process? It is here where you have 2 4 helium simultaneously coming together to produce, with a gamma ray, to produce the 8 beryllium, very short-lived, which normally decays to 2 4 helium. But before it gets a chance to decay, there's another 4 helium that comes in because it's very, very dynamic. So it's almost a 3-body interaction, and you get the 2 gamma rays coming out, and you get the formation of 12 carbon. Okay? But we don't see gamma rays. We don't see the gamma rays that are supposedly coming out from the other process. So in the proton-proton process, there's gamma-gamma. We don't see those. And in the CNO cycle here, we've got a gamma here, a gamma here. We don't see those gammas, okay? And in the triple alpha process, we have these So maybe that isn't what's going on. Maybe that's not what's going on. You get the same products. You'll see the same spectral lines, right? But you don't have the same overall process going on that they're proposing in here. Now, what it's saying here actually is, look at this. As a side effect of the process, some carbon nuclei fuse with additional helium to produce a stable isotope of oxygen. There we go. 12 carbon plus 4 helium goes to oxygen 16 plus a gamma ray. Okay? That is what they are arguing is going on in the triple alpha process, and an extension of it. It does lead to the production of 16 oxygen in this way. So that is that. So hi guys, thank you. So it's a little bit intense, this one today, but I think it's worth it. So these are the various processes claimed to be going on in the sun. Now, I'm going to show you, using the Parkhomov-inspired MFMP reaction calculators that were programmed by Philip Power, thank you, Philip Power, that if you have HCNO and you put this equation, or rather this expression query into the nanosoft.co.nz fusion calculator with H and D in your input 1 and carbon, nitrogen, oxygen here, we see the initial hydrogen with an antineutrino coming in and another hydrogen fusing to make deuterium. That's a positive yield of 1.441955. Okay, that is the initial reaction. You will see what has now apparently been proven as fact by the work of Binja and Huang and Taipei University Department of Energy. A proton with an antineutrino and electron, of course, coming into oxygen 16 to produce oxygen 17. There we go, 3.35897 mega electron volts. So if this is proven to happen, I think it's reasonable to accept that this can happen. And this is the first step in the proton-proton chain, which means we are doing nuclear synthesis. Okay? Now, as we go up the chain, what do we see? If we have deuterons formed and we have carbon, okay, then if we go to a first deuteron here with carbon 12, this is our carbon 12, we get nitrogen 14. And right at the top, if we've got nitrogen 14, look at this, 20.8925 million electron volts. If we've got nitrogen 14 and we have a deuteron coming in, we get oxygen 16. There we go. We have first to do this reaction. The first step in the proton chain. We are in our exotic vacuum objects, in our fractal toroidal clusters, these toroidal geometric structures with these intense magnetic fields. It would seem we have already seen proof, possibly, let's hope it is the case, of this reaction here, which needs more energy, or rather it yields more energy. But anyway, I think it's reasonable to expect that we get this. And if that is the case, I have no reason to think that we don't get reaction 296 here down the bottom, 296, leading to nitrogen 14, and 298 leading to oxygen 16. And because nitrogen 14 occurs before the production of oxygen, it stands to reason, therefore, that you might get more nitrogen in your atmosphere than oxygen, because you have to do the nitrogen synthesis first. Now, the carbon synthesis, all of these reactions seem to produce carbon, whether it's fissioning or fusing. To get to carbon, you can make, you could make an alpha particle and then smash them together, but it all happens at the same time. If you've got deuteron here, all you do is you add 6 deuterons together and you make carbon, okay? But carbon is so stable it gets kicked out, let's say, so you get some carbon synthesized. But a process that would produce carbon and also produces deuterons from protons and electrons and antineutrinos would then go on to produce more nitrogen 14 here in reaction 296. And then once there's a lot of nitrogen 14 in the same process, it would go on to produce oxygen 16. So it's not surprising, therefore, that you would get more nitrogen in your atmosphere than you would get oxygen. Okay? Alrighty. Now, once you have your carbon, nitrogen, oxygen, what if you react those two together? What do you get? Well, you get these reaction products. You get magnesium, sulfur, silicon, aluminium, phosphorus, silicon, and there we go. So we know it produces sulfur. We've seen that. Silicon, I've given you many examples where you can see silicon. Phosphorus has a very low melting point. It could be kicked out. This doesn't turn up very often, actually. Okay, but it has been observed. Aluminium, we saw aluminium. We've seen magnesium in cavitation spots on Roy-Shinamaza. It does appear in other LENR experiments, but there's silicon here, the aluminium, and so forth. Okay. Now, once you have your silicon and your magnesium is basically double carbon, to be honest. When you have magnesium and you have silicon, so forth, let's add a third step where you have carbon and oxygen, which you know you've got, and you have calcium. You want to try and create calcium. How do you do that? Well, what you need is silicon or magnesium or aluminium or phosphorus, so basically everything that gets synthesized pretty much in the previous step here, these elements here, when you combine them with further carbon or oxygen, you get the synthesis of calcium. I could go on to the iron, but I've already done the iron. So we don't need to do the iron. There are exchange reactions which we can do. I can just show you what those are rather than straight fusion reactions. Let me pull that up. And it is here. So in this, we've got a 2-to-2 reaction here. And if I zoom in a bit, I'm saying CNO, CNO, and E4 is calcium. So if we have our silicon and our sulfur here, let's say, and our carbon, oxygen, and nitrogen here, we end up by producing all the isotopes of calcium plus either helium, hydrogen, or deuterons. Triton is unlikely to produce because it's radioactive. It would decay in the process. So with these in play, then they would just go round and form more carbon or whatever. Okay, so you would end up reiterating almost instantaneously to the products that we see across these 3 slides. Okay, so this for me is a watershed moment in our journey, friends. When I saw those plasmoids, absolutely, categorically what we have seen before, totally what has been seen in the Geet, but to another level. For me, it was, okay, we need to deal with the risks here. We don't want anyone to come along and be a party pooper, you know, and we have a good understanding of how we can build detectors potentially for these things using Josephson junctions or something similar, and other means of detection like zinc sulfide, silver activated screens, or, you know, some of these X-ray photomultiplier type screens, or potentially reverse bias diodes, or with PTFE or fluoropolymer activated webcam monitoring. So I'm going to try and employ all these technologies to understand whether they're getting dark mode evos coming out, or rather strange radiation coming out, and then showing mitigation and range of safety of these things. So I want to deal with the safety issue. It's got to be a safe technology, and I believe that we have a sensible understanding such that we can build this safe. Okay, that to one side. If the white powder contains silicon, iron, calcium, and oxides thereof, and the other products that I've shown you in a ball lightning breakup today, in the scales and the morphologies that we have learned to expect from this process, then categorically it will 100% be a ball lightning related technology. Boom. Perfect. Now, if the carbon is being captured either by being synthesized to nitrogen and oxygen, as I've just explained, in the CNO cycle that uses deuterons instead of something that would yield gammas and works in a sort of wonky backwards way, right? Produces nitrogen and oxygen, and or it produces the same carbonized film that we have seen in multiple systems and replicated from the work of Takaaki Matsumoto. If it produces calcium, that is in the form that we have seen in a number of different experiments, or if it produces silicon that we have seen by capturing a carbon and an oxygen, fusing to make silicon, if it does those things and captures it into a white powder, we have an hilarious opportunity here. We have the biggest FU you could possibly imagine, to possibly a scheme that was hatched a year before I was born, just 51 years and 1 day ago. It would be 52 years ago that the scheme was hatched of the climate narrative. We have an opportunity to, as I said in February, turn this on its head, literally use their arguments against them. Because you could have a vehicle, an internal combustion engine, or a gas-burning furnace, or another generator of electricity using gas or oil or whatever, that could sequester carbon from the atmosphere, such that you would get carbon credits for driving more miles, heating your house more, or generating more electricity through a hydrocarbon. That would be, to me, the most hilarious thing ever. And you know what? It would be, you see, what's even more interesting is when I started on this LENR journey, I thought, you know what? When you have a LENR reactor all of the people with oil and gas are going to be your worst enemies, and you're going to end up causing those people the worst degradation in their extremely high standards of living. These areas of the world that have a large amount of hydrocarbons in the form of liquid and gas, they could be your enemy. This turns that on its head. The people with the money and the oil and the gas become your friends. The people that have not got money, have got debt, or they're unwilling to use their hydrocarbons because of principle or because of political expediency, they are then given an open book to say, look, we can literally use these things with a good conscience. And you don't need all of the nonsense. It's literally hilarious. So I have to see it for myself. But what we're looking at, and he sent me pictures of his thunderstorm generator with these marks around it. And I have to say, at first glance, they do look a little bit like these. And if you recall, these are the ball lightning trails coming from the center of the Vega Valley and moving over the zinc, copper, zinc oxide, and calcium oxide surface. Every one of those things that I've just said, zinc oxide, zinc, copper oxide, are diamagnetic. So the intense magnetic field in the ball lightning structure will cause it to skip along the surface. But because it also is incredibly good at ionizing, and also breaking up electron bonds, you get this churning effect going on. And if you look at it a little bit closer, you end up seeing something like this. And when they break down, you can literally see it. We now understand this so much that you can understand what you're looking at here. At the end of this ball lightning trail here, you have a geometric deposit of carbon. Okay? At the end of this one, which somehow managed to fly through a gap and start doing a little bit of work over here, it started here and worked backwards, you have a deposit with a ball in the center. At the end of this one, you have a carbon deposit here. At the end of this one, you have a pentagonal geometric deposit, okay, where this one kind of like got isolated. Okay? So we can understand what these trails mean. And I believe you can't micro machine this. You can't fake it. He either has got crenellated iron-rich spheres, calcium oxide fractal toroid structures with, typically you would see this carbon deposit in and around both of those structures. Fragmented silicon dioxide, fragmented calcium oxide in particular types of morphologies, carbon films, these kind of things. And this kind of thing here, right? If he's got these things, he's got the right thing. Okay? So, what he's told me also, for instance, the thunderstorm generator, it's known that it's copper. It's annealed in such a way that they impregnate it with nitrogen. It works. I can tell you why it works. For the same reason that Matsumoto used copper. It does not absorb hydrogen, does not adhere to it. It's diamagnetic. So if you have a cluster which has a magnetic moment, it doesn't like to be there. If you have a proton or a atomic hydrogen, it doesn't like to be there. It doesn't like to do it, okay? So it's kind of bouncing off it, right? And then, but you might have some crystal grain boundaries or whatever and stuff. If you impregnate nitrogen in there, nitrogen on its own is diamagnetic. So you effectively have something that's like a kind of magnetic shield for the plasmoids that have been produced, as he calls them. As I said, Matsumoto and so forth, they don't think plasmoid is enough to describe it. But anyway, it's fine. Fractal toroidal structures do not like to go into that thing. Now, if it gets too big, their flux loops will penetrate, and then the structures can maybe carry on over those. And I think that's what you're seeing when you're seeing these things coming out. I would like to see if there is damage to a device where that has occurred. Certainly, they've had some things happen in the past. But I think we know what to expect now. So with that, I think we're facing an incredible opportunity. And for me, as I said at the beginning of the presentation, sometimes you have to see what the universe is trying to tell you. And when I chose to walk up the street and see my friend and colleague taking a photo of this protest/petition outside of our offices, opposite our offices, I knew what I had to do. Because you couldn't get the universe giving you a bigger signal. Of all of the places in the city, it's a big city, right? They happen to set up shop opposite our office and put up this thing that says, this is a petition to save petrol and diesel cars. And let's say no to the banning of combustion engines because we want freedom. We want freedom. We don't want someone to say, you're going to drive your self-driving car and it's going to be electrically powered. And if you haven't paid this, or you haven't voted like this, or you haven't agreed with this narrative, then you're not going to be able to drive because we're going to turn off your electricity. And that's what everything is running on in your life. Okay? You're not even going to be able to use an electric vehicle. No, nothing. Because carbon. Well, if a hydrocarbon engine can not emit carbon dioxide or carbon monoxide, and by the way, the Geet is claiming to be 30, 40, 50% more efficient. If you are more efficient, you will, by that level, you can raise the standard of living of so many people because you've effectively found 50% more oil reserves. And it's literally like a gift from God. It really is. You cannot make this up. This is the time. This is our time. And we've got to seize it. We have got to seize it. And what I can say is it looks like the technology has been verified. I need to see that and understand it for myself. Certainly, I can look at the ash products, which I hope to have in a couple of weeks. And I've been promised that I will get parts of reactors of the thunderstorm spheres to look at. You cannot possibly fake the signatures. You can't do it, right? So if they've got them, given the video that I will try and find it, and if I don't find it in a minute, then you will have it. It will be in the blog. When you see this, you will know that it is true. And when I have analyzed the ash, I will know that they have it. I'm not saying that they're producing more than Unity, or rather, they're not producing over Unity necessarily, but they're just more efficient. But if they're producing anything more than 10, 20, 30% more efficiency out of the same engine, that is a massive change. A massive change. And if they're doing that without any carbon dioxide or carbon monoxide, it is the biggest FU to the entire scam that is being set up for us. And the most hilarious thing in the world, I cannot stop laughing about it, is the idea that you would get paid carbon credits for driving an internal combustion engine more because you were taking carbon dioxide out of the atmosphere. It would be utterly hilarious. This operation looks like it has a lot of support and funding behind it. And in that case, I do like the way Geet would appear to fractionate and break up molecules that are coming in. And there's no actual reason in my mind why the technologies cannot be combined, actually. But just having a modification, a relatively simple modification that can be made without all of the problems associated with getting the Geet diameter of the rod right and the angles of this and the connections and whatever. If it's simple enough to build this version of the technology that removes CO2 and CO from the output of an internal combustion engine, it's literally a bomb of unimaginable proportions on the global narrative that is setting us up right now. It's definitely still exploding, Baron Arcanus. He's saying, is it an implosion engine? There's obviously implosion going on. And that may actually be part of the case. So Stephen says, I'm looking forward to seeing a video of thunderstorm generator. Is it harmful to be standing near it? Also, Tony Yaboni sent you an email with a link. Oh, maybe. Okay, I'll have a look. All right, I'll see if I can find that. So Stephen, the first thing I said to them is I'm not so much worried about, because they said, oh, we know how to stop it producing those things that are coming out of the thunderstorm generator. I said, I'm more worried when I can't see it. At least when I can see it, then, you know, I know where it is. It does appear that it comes out and goes back in, and this is consistent with the Lion reactor. There is a flux loop, and what I think is the case is the monopoles, yin and yang, are getting stuck inside the reactor, and it's the flux loop that's coming out. I'm not so worried about that. I believe that has a maximum distance of around about 20 centimeters, based on the study of Parkhomov and Zhigalov, and also the 22 centimeters from the nickel hydrogen reactor of Zatelep and Baranov. What I'm more worried about is when you get the clusters in the neutral state and they unwind in the magnetotor-electrical radiation. Those are seen to have a range of about 700 meters. Okay, so that is where you need shielding in place. The thing that I'm more worried about than either of those things, because you can always go further away from a reactor, and you have a, you know, dilution is a solution to pollution, right? So would say 9 Sigma doing the TEPCO tritiated water disposal. Anyway, what I'm more worried about is the coherence of chi force from the environment. And again, we know that is likely to have a fall off, and so there will be a range. This might be this 20 centimeter kind of boundary from any particular normal sized exotic vacuum object. So I would like to understand that, and it might be that we need to get some atomic clocks and look at their time rate of decay and bring them closer and closer to a working thunderstorm generator to find the zone in which the atomic clock starts showing a different time progression. Okay. So that's there's other methods to maybe explore this, but it's more, I'm more worried about those things that are being sucked in to facilitate the reaction process. If we can get a decent toroidal moment detection device, a Josephson junction based device, then we should be able to optimize the amount of reaction profile. Like, we just want to get to the point where you have extra efficiency and you are not emitting carbon dioxide or carbon monoxide, so we can deal with all the nonsense around global warming and why no one should be having any hydrocarbons anymore. And we can empower those people, like America with its beautiful resources, and Australia with its beautiful resources, and all of those countries that have got these untapped, and also methane hydrates. Hydrates. There is an unbelievable amount of methane hydrates in the deep oceans that using this process would yield, in my view, no, if properly applied, and if this does work, unimaginable amounts of energy, but without the resultant carbon dioxide in the atmosphere. So we have a huge and incredible, beautiful future if this is going to be able to deliver the promise it looks like it may be able to. Okay, so I will have a look to see if that's got the video on there. So let me look. So Tony Jaboni has sent me a video. Or a link Where did he send it? Where did he send it? No, 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 I don't see there. Okay, so maybe you sent it here. Okay, all right, that's that. Maybe that's what you're looking at. Okay, yeah. All right. Yeah, okay. That is the one. So we will, let me just get that. So this is public. I will add the video to the, so thank you, Tony, for finding that. It may be the same video I have, I don't know, but anyway, I think it's good enough to get the point across. Okay, yeah, it's in this part here. Okay, so you see it there? Okay, I'm gonna actually. Look at this in QuickTime, and then I can actually step through it. Okay, there was one there. There you go. That's one leaking out of the pipe. Okay, there's another one there. There's one coming out of that side. Okay, there's one, right. So this is coming out and going in. And so I would suggest the north and the south pole are here. And this is doing something similar to what was going on in the Lion reactor. Okay. Okay. There's another one there. There's another one. Okay. There's one that's actually come clean out of the device there. Okay, we've got some funky action over here. Quite a few going on there. Okay, that's coming out and in. This is encouraging. That one's fairly free. So I'm not so worried that the ones that are going out and in, although you still don't want to be, in that zone. It's the ones you can see are not the ones I'm so worried about. It's the ones you can't see and how far they are going. So I would like to get an atomic clock and some other things. Maybe some cobalt 60 sample would be good, strapped to a detector. I'm just going to play it now. Yeah, so this one's knocking out quite a few. Oh, wow. It really went mental there. Look at that. Okay. Oh, that's interesting. So in this one, I would suggest that this is part of the vortical moment that's going on in here. And it looks like that has traveled. So it starts there, and then the next frame it's up here. So it's like the north and the south pole are riding up, and it's carrying the flux loop along with it. Yeah, I mean, there's one that's coming out and in. So there's one back there that's kind of well in the free space. Of course, Yeah. Oh, there's a fairly large one. Yeah. So this doesn't have a rod in it, and it's more simple to implement, I believe, than the Geet. Okay. Yeah, so that's definitely doing it. That one early on was really quite nice. So right back at the beginning, you could definitely see it coming in and out. So let's go back to that one. Okay, there you go. That's kind of like beautiful, really beautiful. Look at that. Okay. Okay, I'm going to look at your questions now. So Stephen B. Hall says dark mode evos pass through the containment, then become back into our reality and cause light ionization. I think what's happening is it gets excited as it goes through the metal, and it might just be like, if you could imagine you've got a flux loop, and ordinarily it's pointing together like that. Okay, and then it bends, and it's just like the kink of the flux loop passes through the reactor. Reactor wall. Yeah, I'm not so worried about these things, but like I say, there's a range. You know, I'd have to think about it for a little while, but I've got a whole range of different ways that I would like to investigate this phenomenon. So, firstly, I would like to see what kind of phenomenon there are around a normal working reactor. And keep things at arm's length. Yeah, so. But this video for me was a no-brainer. I had to accept the invitation to speak with him, and you know, if the claims are true, they are in line with what Paul Pantone said. But like I say, I believe it's simpler, and just delivering the no CO and no CO2, even with normal levels of efficiency, would be a huge bonus. But if the efficiency is higher, then you can raise the standard of living of so many people in the world, and you can mine those hydrates, those methane hydrates, and you know, we've got a very, very bright future for humanity. So Corky says, question, will you be in discussions with Randall Carlson as alluded to earlier? Yeah, I was meant to speak to him last week, and I think I might speak to a couple of people that are in that area in the coming weeks. But we'll have to see how that goes. I did speak to him briefly in the first call, but not more than that. I think we have a lot to share. The safe no, well, I think the safety. So Geometrics 999. I understand you've got some connection with Malcolm. Great, thanks for joining us. Yeah, I think we don't need to be caught short by announcing a technology that completely inverts the global warming. You can't use gas or oil anymore. You have to use what we're telling you you're going to use at pain of going to prison, as is the case, it would seem, in the UK and in some other jurisdictions. By turning that on its head, we don't want to give them any excuse for pulling a device from the market. Okay, so fortunately, most of this work has been done. The effects have been observed. We've observed them. Other people have observed them. I think we have a reasonably good understanding of what is going on, what is potentially coming in, what is potentially going out, their field of effects, and so and ways to detect them, and ways to mitigate for them. And almost everything is patent free. So that for me is good. And so yeah, this is just an immense opportunity, and it is a real spiritual moment. Yeah, real spiritual moment. Yeah, I actually think that there are things that Malcolm is doing that are unnecessary, and there are things that can be improved, greatly improved and simplified. But already it is, in my view, simpler in many respects to Geet, and it seems to be more reliable to get the end product. And clearly it is doing the job when you see this. And if the products in the white powder that is being claimed to form are as expected, or I see them in other parts of the reactor, like I say, they cannot be faked. They will be specific morphologies, you know, natural ball lightning, ultra experiment, discharges underwater, Vega experiment, all producing the same structures. So, like, they don't have a separate universe. It will be working in this way, and when you see that, it's definitely working in this way. Yeah, Geometry is saying these external evos are only seen on overdriven systems that are not sized correctly. Okay, but for me, it's definitely a point to come in. But I'm like I say, with the Lion reactor, it produced exposures onto X-rays when it was turned off. It was taken out of the reactor and put into a biscuit tin with X-ray film, and the X-rays were exposed. So no one saw anything going on, but it still exposed X-rays. So not seeing them is more of a concern than when you're seeing them. For me, it doesn't mean they're not there. It just means you can't see them, and you can't detect them with a neutron, beta, or gamma detector. You just can't see them, like with those, right? So it isn't a case of being comfortable that you can't see the danger. We have to address the potential that the danger is there. We know that it is and has been observed in other systems, and therefore, as this will be the same technology, because we only live in one universe, we need to address, detect, and mitigate. And I believe that we can actually utilize this to gain extra heat. And so, you know, there are opportunities in knowing where the radiation is and where it extends to, and properly addressing that before the rollout. But the potential here is so freaking huge. It's mind-bendingly huge, that these things will be overcome. We will overcome these things. Yeah, I mean, cavitation is the same thing. As clearly demonstrated by the Amasa vibrator plate. So I think it's about finding the right materials. I think we understand what drives the process and what it doesn't like. I think what's been chosen in terms of nitrogen impregnated copper, I think it's not a bad solution, actually. But I think there's, like I say, layers of things that we can do to go really good. What country would first show interest in implementing the infrastructure for something like Geet? My guess would be Japan. I actually think that your biggest friends on planet Earth are going to be the Middle East, America, because it's probably got the largest oil reserves in the world, untapped, and countries like Venezuela and Nigeria, these countries that have huge oil wealth and gas wealth. You know, for Qatar, for instance, with the gas, these people are going to be very, very, very happy. And they're also sitting, like take Norway, the biggest sovereign wealth fund, bar none. But are they interested in low-energy nuclear reactions? They should be. They should be. If this is going to deliver, because it's just like a slam dunk end run around the narrative of global warming. C says, Bob, are you aware of Putin's occasional references to a new weapon system based on the new scientific principles, or do you think he means it's all the same? That anything interesting is going to be this. So, like, as I've said many times before, in 2017, it was very clear to me that you can make, and there has been made technologies that are there, ready, and probably have already been used to subjugate humanity and change the narrative. And we are actually in the latter stages of falling victim to a long-term control grid that will prevent us from using the possible aspects of this technology. But it is our responsibility, the people that have learned and gone through this journey, to ensure that they don't do it. To assure that the technology isn't used to enslave us via theatrics and stuff that have come after the theatrics, but that the god of ball lightning, as it says in the ancient Sanskrit texts, will end the usurers, will end the whatever it is. As I spoke many moons ago, it is ball lightning that saves humanity from usury. That's what the ancient texts say. I'm sorry, that's just what it says. So, and here we are. Let's stop this usury. I will do what I can, absolutely what I can, to ensure that it's safe to the best of my understanding and ability, to show that it's valid. And as I said, it's kind of pretty easy. It either will be producing these things or it will not be producing these things. If it's producing these things, then in the forms and that they should be able to, that they should exist in, then it definitely will be that technology. And if we see certain things within a sphere radius of the active component, then we are literally at the dawn of an old age. We are literally at the dawn of an old age. Yes, Cosmic Dave, we are at the turning point and there are big supporters on our side. The biggest. Anyone that's interested in high standard of living, easy energy, that doesn't flood rainforests causing lots of methane from rotting vegetation and displaced animals, from horrible coltan and vile mining procedures to get materials for a lot of energy technologies. I mean, wind is completely out of question now, totally out of question, because the biggest wind farm manufacturers in the world, they can't afford to produce the wind farms that they've even been planning to do, for instance, in the US, because they can't borrow the money at a cheap enough rate that will allow them to make money on the 3% margin they were planning to make a margin on. So, like, wind is off the table. So people need to look at practical solutions, and I think humanity has done it. We have rediscovered an ancient technology, and it is literally the technology which I believe the world was running on at some point. Distributed energy is great, but like, yes, this could do it. Like, this is what I'm saying. Don't let them take the internal combustion engine away from us, as they plan to do between now and 2030 or 2035. We must stop this freaking insanity. Once you're on a wire sucking from a tit, and the energy's produced God knows how, but you don't know how it's produced. They know how it's produced. You don't know how it's produced. It could be produced by a fusion technology they already have, right? Probably using this technology. And you're paying thinking they're doing some really difficult job and they're just feeding you free energy, and you're paying through the nose for it. And if they don't like you, they can turn you off. No. Freedom. Freedom. What it says on that slide. This is literally destiny. There is literally no way the universe did this other than to force me to do a different presentation this week. This is real. This is literally only in the city opposite my office, and I only noticed it because my business partner, that's my friend rather, and my office partner was taking a photo of it, and that's what it says. Let's save petrol and diesel cars. Say no to banning the combustion engines. Freedom. That's it. That's all it says. That's all it says. It's hilarious. CC, that sounds good. Sounds very interesting. You know how to connect us. Baron Arcanus, absolutely every one of these systems will be using this technology. Like, every one of them. And they're just variations of it. Freedom, yes. Freedom. Real freedom. Not someone telling you you're free. Real freedom. Yeah, Geometrics, for me, the focus was using this technology to deal with waste. And I was just so disappointed with what happened with Fukushima. But, as more and more implementations of the understanding work, then it's going to get easier and easier to have these conversations where you don't get people in the way that are saying, well, I don't think that works because I read a textbook once and it told me it doesn't work. Yeah, I think Randall and I will have a good sit down in the coming weeks. I think that's going to happen. I do have to do jury service for a couple of weeks first. So if I have radio silence, that's why. Yeah, taking back power, that's what it is. Right, I'm going to go quickly up and see if there's any questions I might have missed. Harry says, sorry, I thought the Geet was a closed loop system. How does it pull in carbon from the atmosphere? Okay, so the Geet normally has air being pulled in, one. Malcolm Bendel's thunderstorm generator is not a closed loop system. It is burning, but it's burning in theory with more efficiency, and it's got energy recovery, of course, and then secondly, it potentially has this lack of CO and CO2 emissions. So we'll take the wins that we can take, and this is a monumental civilization changing win in its own right. So it's a good win to take. And and with the analysis of the powder, we're going to have, we already understand what we're going to see, so if it's there, then it's kind of like done. Yeah, Geometric says there's no degradation in the internal parts. He said the same thing to me. He's had one running for a good number of years. So, and the same kind of thing that was said for the Geet. So, Jonathan Berry, thank you very much for your kind offer. If you can reach out either by the contact form on quantumheat.org, the MFMP's original website, or you can send a personal email or personal connection by subscribing to remoteview.icu, and I will reach to you. Thank you very much. Thaddeus Max says, please God, let this come to fruition. It is our time to take charge of our own destiny. So many people have worked so hard and for so long to understand what is now being laid before us. And we didn't steal it. We learnt how it worked. It is a gift from God, and He means us to have it. It's not a coincidence that this happened. It is not a coincidence. You just have to know the signs when they're there. So Space Gay says, I agree, the plants need the carbon, should not take it out of the air, likely need to put more in the air. That may be the case. The beauty of this system is, as I have showed you, that it should be creating carbon film in this powder. And if that's the case, then, if you burn it, it produces carbon dioxide. So, there we go. If you want carbon dioxide, you can do it. You can regulate the carbon dioxide. So it's, not in a bad way, but in a good way. Okay. Thanks, Baron Arcanus. It was a huge team effort. Diodine Axe, any ideas on how we could implement these technologies in communities? And are you familiar with, yes, of course, energy of return on energy investment? Yes, of course, right? So, if you can combine, say, the Geet technology of breaking up the particles with this, maybe it's not even necessary. So you would just have to find out. But like, whatever your energy is, if this is going to do thermal recovery and gain 20% or 15% over current engines, that's huge. It's just huge. Whatever your EROI was before, this is going to be better. Do you have a plan of action above and beyond your research? The plan of action is verify what's been verified from what we know from our study field over the last 10, 11 years. We know what to look for, as I've said. Once that is verified, other than the visuals that I showed you earlier in this video here, where clearly there are the things that one would expect from a system that is using this technology, then it is to develop devices to detect the radiation, employ them, understand what the relative flux is to the performance of the device, and optimize performance and safety, and remove any form or any problematic potential. I'm not saying it will be there, but remove as best as possible the potential for any issues, right? Of course, first implementations could be very large generators which produce electricity using diesel or whatever. We're not having to worry about the emissions in this case. And then you would get the electricity, provided from that solution. And, finally you could have a clean electric car that way. Yeah. So I guess that's Martin Kemp. Yes. Open source this. Everything I do is open source. Almost everything I've ever suggested is in a video. It cannot be owned. It cannot be patented. That is the way I roll. I understand that there are some patents, but I believe the adage, the justification is that they didn't want someone to patent them and then prevent them from using it. Like I say, my modus operandi is to publicly say it all first, and then it can't be patented, although some might try, but then anyway, it's in the public media. It's just different people go about this in different ways. My view on these things is that the internal combustion engine as a technology has many, many embodiments that are able to be patented. But the underlying core technology isn't. People can make their own internal combustion engine, at least for now. And we need to keep that right. We need to keep that fundamental freedom. Drowning Penguin says, have we seen how these radiation emissions respond to optical reflection and refraction? Well, to a degree, those things have been studied by Alexander Parkhomov, and he used the fact that they can be partially reflected in order to focus them onto beta isotopes. So like I say, I would like to get some cobalt-60. That would involve getting some... I would do it with a check source. And I would see if the rate of decay would change. So there's many different approaches I have in my mind to deal with this radiation question, and we may actually find it may be the case that you can use this process, as I suggested to the MFMP back in late 2012, 2013. Could we use monazite and put a device that produces something that's coming out that we detected in 2013, could we use that and then it does some further work? It could be that you could encase the thunderstorm generator with monazite and it produces fantastic amounts of power. Or you could encase it with a beta isotope like potassium 40 or just potassium, and it produces further yield because it forces the inverse beta decay. So there's so many opportunities to make good of a source of this radiation. Do we know Chinese term for strange radiation? I don't know. I don't think so. Oh, sorry, Jonathan Berry. If you go to, let me just find that. If you just go to quantumheat.org and then just the main page, I think maybe. Let me see. On the top right, there's a contact us. There. Here. There. Quantumheat.org. index.php/n/contact us there. Greer said $100 million. Oh God, this is trillions. It's trillions. It really is. More importantly, as I said earlier, the hilarious thing is, if this really genuinely does do what the Geet claimed, but in a simpler way, and remove carbon dioxide or just every area of the earth that has oil and gas is just going to be your best friend. And these are the guys that got the money, right? So, as I said, I always feared, like, the prevailing fear in Russia even is that, like, by the LENR cold nuclear transmutation and ball lightning group, is that this technology threatens a large proportion of the foreign income for the Soviet republics, and this turns that on its head. It means that they are your best buddies. There's a lot of decent people in there, just like everywhere. Most people are actually quite nice. Yeah, it might be an ideological opposition, but you blow that ideology up. You just completely obliterate it. It's hilarious. It's so funny. It's like, yeah, but you're going to produce carbon dioxide. No, you're not. So what was it that causes global warming? What was it? Was it carbon dioxide? Okay, got that right? Nah, you don't get any of that. Oh, they're going to fight dirty, but the people that want to use their oil and gas and are currently being excluded are also going to fight dirty. Everyone's going to fight dirty because it's a change. Yeah, get over it. Yes, H2O plus carbon arc. Yes, combustible fuel tool. That's essentially what I'm saying in the first part of the presentation back from earlier in the year. So Thaddeus Mac says, I like the idea of changing the name Geet to some acronym like a fun woe, fudge you new world order. Tammy says maybe those in charge don't qualify as people. Listen, there's a lot of misguided people in the world. There really is. No one's perfect. I know I'm not. I know I made mistakes, and to be honest, I'm only doing this because I believe the narrative that was set up the year before my birth. That's the truth. Well, maybe not, but like certainly it played a role because I was so much into, I've got to find a solution. People have been led astray, you know, and they're too trusting, and that's it. Cosmic Dave, you know what you have to do. The thing is, Shanghai, trillions. Money losses all meaning outside the context of luxury items and services when survival necessities are abundant. You know, this has the opportunity to raise the standard of living of the vast majority of the planet in a guilt-free way. And it'll help us to understand more the process that's going on. And this will look like, how should we put this? It'll look like Kitty Hawk or whatever. It'll look like the first Wright brothers plane compared to, hypersonic vehicle, and I think it would go very, very quickly, because I know there's a lot more intelligent people out there than me, a lot more intelligent. They just haven't bothered to understand the technology. They don't have to make all the mistakes that all the other people have made, because they come in at the point that something works and it's got utility, you know, assuming this does. And so, like, they don't have to do all that work, but they can apply their own thinking, and, you know, it will move so quickly. You have no idea. The economic incentives to deliver this, it will be ridiculous. Ridiculous. Yeah, you can build businesses using oil subsidies in the US too. Yeah, so you get money on the in, and you get money on the carbon sequestration as well. Thanks for your kind words, Douglas. But this is only made possible by everyone who's played a role. And so many people. Okay, so I'm going to do a quick review here. This was Ode HCNO, and on the right we have protests that were opposite my office this week, begging people to sign a petition to save petrol cars and diesel cars. Let's say no to the banning of combustion engines. Freedom! So I went back to my comments on the 5th of February 2023 when I thought, well, can we run the world on cow farts? And because I believe they're going to take away your gas stoves in your kitchens and your hydrocarbon-driven car and not allow animals to provide us healthy, nutritious food because of global warming or something, right? And so I said, look, if we have a device that turns that narrative on its head, we can use their arguments against them. And all come out of this smelling of roses. Methane is the cow farts. And, you know, and there's a lot of it flared away here in oil and gas production, and this could be used too. So I proposed a series of equations, or rather reactions, that would explain the helium and oxygen that was observed without the expected gamma if there was nuclear reactions, using Parkhomov's dark matter antineutrino inverse beta reaction processes to create deuterons, and the deuterons, either through this pathway or through CNO, go to produce oxygen, and you get a whole bunch more energy than normal reactions, and methane is the best molecule. It happens because you have magnetic material in the form of free electrons, protons, atomic hydrogen, and furthermore you have atomic oxygen, atomic carbon, atomic nitrogen, all with their magnetic moments that align to the magnetic moment, strengthening this structure and firing the material through a phase singularity at the center. Everything is trying to get through the same space and time. And so it's a targeted fusion device, and it's a thing of great beauty, a gift of nature. And this is one pieces of parts of the puzzle, George Oswa, and replicated by Sundaresan Bokris. And I dealt with this by expanding the prediction I made, which seems to have been verified by Benjamin Huang, whereas the synthesis of 17 oxygen from the inverse beta reaction and the further production of these two predicted elements, and that applying the same logic could explain the work of Sundaresan and Bokris, and that we might like to expect in all of these systems a highly pure iron and oxygen crenellated microsphere in the center, and then in the outside zones, and probably on an accretion disk around it, silicon dioxide, and then on further out from that, calcium oxide, and it's just the way it works. We replicated the carbonized film, and I believe this, along with calcium oxide that you see in the Tors of Tors, the Tors of Tors, the Tors of Tors, the Tors of Tors, and silicon dioxide and iron oxide, particular types of structures might explain the white powder that has been found out of fairly long-running thunderstorm generators. And as I explained, this structure has crash landed on this zinc oxide, and as it did, the remaining vortex of material orbiting around this calcium oxide structure, which is the collapsed wave function of the fractal torus that was there, dumped the carbon payload that was orbiting around it. And it's as a film. It isn't dumped as carbon dioxide. It's dumped as a film of carbon. Okay. And I showed the full breakup of ball lightning, and I will share the full analysis work of that in the blog later in the week, so you can see all the elements that you expect to find, which indeed we do find in these systems. And then you can see the orbiting accretion area here, and I showed that this is basically pure iron oxide, and this is the overall breakup products of a ball lightning. I showed that there's calcium in the flux loop of line. I didn't actually show the SEM data. I can't find that at the moment, but I showed the actual imagery, and it's in the center of the flux loop. And I showed that these elements are produced in the vagocardioid infarction flux loop, and also that the silicon carbide core of Parkhomov's 225-day reactor went from 1 to 20% calcium. If you fuse silicon and carbon, you get calcium. I also showed that carbon is consumed in the diamond in the Lion reactor, and it has these miners, and I said that the Neil Crichton Gold's Lion reactor would probably be one of the most important experiments. And I didn't give a time, I just said that, and that's how I feel about it since the beginning. And a heavier element is synthesized during the course of this diamond deconstruction, and this is carbon being eaten away and being converted into something else. I then expanded upon my presentation of a couple of weeks ago to show, and I just mentioned this earlier, how both monatomic carbon and nitrogen can be paramagnetic. Carbon, obviously, in the plasma of a carbon arc is what was going on in the Sundaresan and Bockris work. Note that the dissociation energy here, 7.4 electron volts, is below that of the dissociation energy here of nitrogen. So it would be easier to do the dissociation of carbon. And of course, carbon is dense when you are doing electrical discharge between it. And nitrogen is just a itty bitty bit. Okay. I then talk through the solar burning process as is proposed as a hypothesis. Yet, as I said very clearly, I don't know anyone that's been inside a sun, so it's just a hypothesis. And then I explained how using HCNO, we see down the bottom here the synthesis of deuterium, as I proposed earlier this year, explaining the Geet. And this is the synthesis of oxygen-17, as I proposed a couple of years ago nearly, for the work of Binger and Huang. So this is effectively a version of this, but oxygen-16 is the target. And that once you have deuterons, you can have reaction 296 here, producing nitrogen-14, and then 298 here, the most energetic of all the reactions. D2 plus nitrogen-14 goes to oxygen-16. This is very desirable to happen, but you have to synthesize the nitrogen-14 from the carbons to start with, and therefore you are more likely to see nitrogen produced more than oxygen, and maybe that will explain the atmospheric abundance. And then there are exchange reactions, which I touched upon, but if you take CNO squared and react them together, you get silicon and aluminium and sulfur and things that we observed in the ball lightning breakup product. And if you take those products and combine them again with either oxygen or calcium, you end up oxygen and carbon, you end up by producing calcium as observed. And then Malcolm Bendel and some of his colleagues have sent me some fairly blurry images that give an indication that they may have seen these kind of effects. Copper oxide, zinc oxide in this case, are both diamagnetic, and so is zinc and copper. And these are the tracks that are, as the ball lightning is being moved between the two brass plates on the Vega Valley, there's a brass plate above this. It's traveling down from the central channel, and it's meandering around, and then it decays, and it leaves these geometric carbon-rich deposits at the end of the decay. This is maybe an octagonal one. This is a pentagonal one here. There's a trail up here to a death point here. There's a death point here with a carbon deposit. And in various places you see them. And so that was Ode HCNO. So, thank you very much for your time, and I will see you in the next video. Buenas noches, dobro noc, good night, buenas era.